So let's look at another example. So let's say at a recent high school chess tournament, participants recorded whether or not they had the first move as well as if they won or lost the game. So how might having the first move in a chess game impact the player's overall strategy and likelihood of winning? So let's look at what we have here. And you can see I've kind of filled some of these spots in. Okay. In the table below, F represents those who had the first move. So first move, this is F complement. So if F is the first move, this would be not the first move. And then W represents who won, and then W complement would be who did not win. So again, we're looking at complements here. They either won or didn't win. They either moved first or didn't move first. Okay, and here's the number of ones that moved first, and there were 8 that didn't move first, so that won. Okay, so this is kind of how the table is. This is a contingency table, and it was filled in for us for the most part. So ones that had the first move and won, there were 10 of those. Ones who did not have the first move and won were 8, and so the total who won were 18. The total who moved first was 17 because we had 7 that moved first but didn't win. And then we had 9 that did not move first and did not win, and that was a total of 16. So you can kind of see how a contingency table works. Here's the totals, and then 34, this box right here is the total that were sampled, or the total that we're talking about here. So find P of S and P of F of C. So what's the probability that the student moved first and the probability that they didn't move first? So is it possible for one student to have the first move and not have the first move in a chess match? What do you call these types of events? Okay, these are complements of each other. Okay, what's the probability that somebody had the first move? So that's P of F. Well, let's look at that here. So out of 34, if we're looking at all of these, the probability that the person had the first move. So that would be, here's the first move right here. So there were 17 that had the first move. So 17 out of 34. Okay. Now what's the complement of that? Well, we could just subtract this from 1, because remember, 1 minus P of F would equal the P of F complement. And again, it could be the little prime. Here they're using the C to represent the complements. So we can look at it this way. Or we could look at, well, it looked like there were 17 out of 34 as well. So the probability of F complement is also 17 out of 34. You know, what do you call these type of events? Well, these are events that are complements of each other. They either move first or they didn't move first. And it just happened to be, since these were both the same, that the probability is the same of whether they move first or didn't move first. Okay, let's look at our next slide. So it says mutually exclusive events. If event A and B are mutually exclusive, then this says probability of A or B equals the probability of A union B equals the probability of A plus the probability of B. So there's no overlapping in these. For example, if we look at the probability of they move first or didn't move first, there's no in between. They either move first or they didn't move first. All right. So mutually exclusive. It's two things that can't happen at the same time. All right, so let's calculate probabilities here. again, F represents those who had the first move, and F of C or F complement, they didn't have the first move. So let me just go ahead and I'm just going to write these in here like we had in our previous box, 17 and 17. And then we'll use our contingency table here to find the probability that the student did not win. So the probability that they did not win, that's win, the complement of win. So that'd be if they didn't win, that means it's the complement of win there. So how many? So that the student did not win. So that's all they want to know. So here's the row that deals with how many did not win. Well, it looks like 16 out of 34 did not win. Okay, and we could reduce that 16 out of 34, which is actually, if we reduce it 8 out of 17, we can reduce it by 2, which is 8 out of 17, or approximately, if we round it, 4706, and that's rounded to 4 decimal places. So that's the probability that the student did not win. Okay. Let's look at the next question. Find the probability that the student had the first move and did not win. Okay. So the probability that they had the first move and did not win. And I'm using the symbols they give us up here. And this is the intersection, so that means both of these had to be occur at the same time. This means this is the probability that they did move first and did not win. So there were 7 that moved first and also did not win. Okay, so 7 out of 34. 7 out of 34 went first, had the first move, and did not win. Okay, and that's one thing I like about contingency tables. It's pretty. To me, it helps to find these kind of probabilities. And if I do 7 divided by 34 to get me a decimal, and then we can look at the probability there is rounded to 4 decimal places. So it really depends on what the question's asking. Okay, very good. Let's move on to the next slide here. So what are we looking at, or what should you take away from this? Well, one thing is and. We talked about or is add. And means both events must happen. So this is the probability of A and B. We use the intersection symbol right here. The relative frequency of events A and B must happen in the same outcome. Okay, that's like the probability that they went first and did not win. So that was the probability that we're talking about there.